Just call me Dishali, but not ma'ams or sirs. It's okay. How will you be presenting your writing board work
Yes,
today?
yes, ma'am. I am sharing my screen. And here it is saying that sharing is not turned on.
Raghav
Let me check.
sharing.
Can you share now? Check once. I have allowed from my side.
Yes, yes, sir. Ma'am, is the board visible?
Yes, it's good.
Yes.
Divakar sir, please go ahead.
Yeah, hi Soumyojit. How are you?
Hello, sir.
All good?
Yes, sir, I'm good. Yes, sir, I'm good.
Yeah, tell us about yourself, including academic
Sir,
backgrounds. Like, okay.
okay, sir. So, good morning, sir. I'm Soumyojit. I am from Noihati. I have done my schooling from Noihati itself, and then I did my graduation in statistics honors from St. Xavier's College, Kolkata. And I have applied for both IIT-JAM and ISI Mstat exam. I have qualified the IIT-JAM exam along with the written part in ISI Mstat examination. And currently, I am preparing for the interview.
Mhm. Okay, what was your rank in IIT-JAM?
Sir, it was All India rank 9.
9.
9, yes, sir.
Okay, so you prefer ISI or IIT-B or
Yes.
Kanpur?
Sir, I have chosen IIT Kanpur.
Okay, why?
Sir, actually, I am a bit interested in research. So, if not ISI, then I have chosen IIT Kanpur because it has some better research aspects.
Okay. Mhm. So for mathematics, what you like the most?
The linear algebra part.
Good. Do you know what linear transformation is?
Yes, sir.
Okay, write the definition.
The linear transformation is free from a vector space B to B. This function is called a linear transformation. If it satisfies that T of x vector plus y vector equal to T of x vector plus T of y vector, where xy vector belongs to B, and the second as axiom is alpha x vector equal to alpha into P of x vector, where alpha belongs to any real number and x vector belongs to the vector space B.
Okay, is it necessary that alpha belongs to R or some field?
Sir, alpha can belong to complex number also. So I think it's not
Okay,
necessary.
again, my question is still open. Like, is it necessary alpha belongs to complex number?
Uh, no, sir. Actually, we can also represent a real number in terms of complex numbers. So not necessarily complex. Alpha can be any number.
Alpha can be any number. Okay. Okay, so write an example like T of, I am giving you an example, then you should tell me is it linear transformation or not. Okay. T of x comma y equals to bracket x square comma x bracket now. Yeah. Is this linear transformation?
No, sir. I don't think so that this will be a linear transformation.
Okay. Which property? I mean, it is not satisfying.
Sir, I think the first property will be violated here.
Not the second one.
No, sir.
Okay. Okay. You know what vector space is?
Yes, sir.
Okay. Rather than its vector subspace is.
Uh, the vector subspace is also a vector space, so it will be a subset of the vector parent vector space.
Okay. So you know there are three conditions to check vector subspace.
Yes, sir, I know the two conditions that the
Okay,
closed
okay, okay.
under
Two
addition
conditions.
and
Okay. Right.
okay. Sir, actually, we can also combine the two condition in one condition. As if
Yeah.
x vector and y vector belongs to V, then we have to check that whether alpha x vector plus beta y vector also belongs to the vector space V. If it satisfies, then it also satisfies the two condition.
Yeah. Okay. So in question one, when I asked linear transformation, uh,
Yes, sir.
is it necessary from I mean T is from V to V, or it may
No,
be
sir.
some
Actually,
other vector
no, sir.
space?
The dimension of the vector spaces can be different. It can reduce a higher dimension vector space to lower dimension vector space also.
So it should be T from V to W, right?
Okay, sir. Yes, sir.
Okay. Again, is it necessary that both should be finite, or
So the vector spaces.
okay? Yeah. Finite dimensional vector spaces are necessary for a linear transformation, or
Sir, I think it is necessary for the linear transformation to be finite vector spaces.
okay. So do you know some example of infinite dimensional vector space?
No, sir. Currently, I'm unable to recall anything about.
So and okay. My next question is, you know what idempotent matrices is?
Yes, sir.
Yeah, write the definition.
Sir, okay, sir. The definition, and A have to be a square matrix.
Yeah, very good, very good. Okay. My next question is, what are the eigenvalues of idempotent matrix? I mean, what are the possibilities?
Okay, so the eigenvalues of an idempotent matrix
Yeah,
can be zero or one.
idempotent matrix. Eigenvalues of idempotent matrices.
Yes, sir. It can be zero or one.
Prove that. Prove that.
Okay, sir.
Explain whenever you write.
Okay, sir. Sir, if we consider lambda to be the eigenvalue of A with eigenvector x vector, where x vector is non-null vector, then we can write from the definition of eigenvector A x vector equal to lambda x vector. So if we multiply both sides by A again, so A square equal to A lambda square x equal to lambda into A x vector. That as A is the idempotent matrix, so A square will be equal to A x vector equal to again lambda square x vector. So we can say that the lambda equal to lambda square here for an idempotent matrix. And if we then calculate it, then we will get that lambda will be equal, either equal to 0 or equal to 1, or lambda can be both.
Okay. Okay. So, okay. My next question is, if all the eigenvalues are 1 for an idempotent matrix,
Yes, sir.
can you say something
Yes,
about that matrix?
sir, if all the eigenvalues are 1, then I think that it is only possible for the identity matrix that all the eigenvalues are 1.
Okay, write a matrix. 3 cross 3. 1, 1, A, 1, A. No. Write it again. Write it again. 1 A B. Okay, next. D. Okay, okay, it's B. 0 C 1 0 1. If this is idempotent matrix, then what will be the determinant of it?
Sir, if we consider if it is not an identity matrix, so in case of identity matrix only, I think all the eigenvalues will be one. So if it's not the identity case, so it will have at least one zero eigenvector, eigenvalue. So the determinant will be always zero.
Very good. Fantastic. Excellent answer. Very good.
Thank you.
Okay, so my next question is, diagonalizability.
Yes, sir.
Okay, can you, first of all, can you construct an example of a matrix which is not diagonal but diagonalizable?
Sir, for non-diagonalizability, we will have, if we don't have the all eigenvectors to be linearly independent, then we will have the matrix won't be diagonalizable. So,
Yeah, see, just write an example. Then we will judge.
sir, actually, I can't think of any example right now.
Okay, okay, okay. Okay, next question is, so you know the theory behind the diagonalizability, right?
Yes, sir.
So if I'm asking like, it's a very, very simple question. Everywhere, I mean, ask this question. Rank of idempotent matrices is trace of idempotent matrix. You know this?
Yes, sir.
Why?
Uh, Sir, if we do the diagonalization on an idempotent matrix, then we can find a diagonal matrix where the diagonals are the eigenvalues. So now the diagonals will consist only of 0 or 1. So the trace of the and now the definition of rank would be rank of that. Sir, can I write something on the board?
Yeah, yeah, sure.
Okay, sir. Sir, if
You are
A is
free
the
to write
idempotent,
anything.
okay, sir. If A is the idempotent matrix, then we can find a matrix Q. The Q transpose A Q, it will be D, where D is a diagonal matrix consisting of the eigenvalues at its principal diagonal elements. So now rank of Q transpose A Q will be equal to rank of D, as Q transpose and Q both are non-singular matrices, and multiplying a non-singular matrices by non-singular matrices don't change the rank of A. So the rank of D will be is non-zero rows or non-zero columns. We can say both. So the non-zero rows will be the number of rows where the one element is present. One element is present as the eigenvalue. So it will be same as if we sum the principal diagonal elements. That is the sum of the eigenvalues. So that will be equal to the trace of A, and this rank will be equal to the rank of A.
Okay. Are you sure about, I mean, your definition of diagonalizability? Like, there should be Q inverse, I think, not Q transpose.
Yes, sir.
Okay. What is nilpotent matrix?
The nilpotent matrix is if A is an nilpotent matrix, then we can say that a square equal to null matrix.
Right, right, right. Are you sure?
Sir, I think that in terms of in step of the square, it should be some P. I'm not very sure about it right now.
Okay. Okay. Yeah.
Sir,
Thank you. Thank you so much. But it's okay. Yeah. You want to say something? Then it's fine.
no, sir. Is it will be P or um,
No, I will. I will tell you. I will tell you in the last.
okay, sir.
Okay.
Okay, sir.
Yeah. Okay. Okay,
Thank you.
Swamiji. Thank you. Thank you. Thank you. Yeah, Raghav. Go ahead.
Hi, Soumyojit. My name is
Hello,
Raghav,
sir.
and I'll be asking the probability part today.
Okay, sir.
So we'll begin with a very interesting question. Right. So say I've given you a coin, and I'll say the coin is biased. Right. So say the coin is biased. Right. And you want to conduct an unbiased experiment from that coin. How would you do that? You can toss the coin as many times as you want.
Okay, sir. If we say the coin is biased, and we consider that probability P as the probability of head,
Okay.
so and Q as the probability of tail, where Q equal to 1 minus Q.
Okay.
So if we toss the coin, I will think 2 times, then we get the sample space as HH, HE, TH, and PT. So I think if we toss the coin some 3 times or 4 times, then we can collect the sample spaces as like 2 or 3 sample points as one sample, and then can construct the probability. And if the probabilities are equal, then we can consider an unbiased experiment with that. So
Okay. And what if you get something else? Like so, like you have written the sample space, and can you find the okay, you have written the sample space, write the probability of all these 4 events.
okay, so probability of HH will be T square. Probability of HT equal to probability of TH. This will be PQ, and probability of PQ, this will be Q square.
So do you get any idea from here? We are trying
So
to do what we are
I
trying to
think
do.
yes,
Right.
sir.
Okay.
Uh, yes, sir. Sir, if I consider this HH and PT as one favorable outcome, then the probability of this thing will be P square plus P cube. It will be again equals to P.
We are trying to eliminate the P out of the equation, right? Because we're trying to
Yes, sir.
eliminate the P out of the equation. So
Yes, sir.
if when you're tossing the coin twice, are we able to obtain two such events that have same probability?
Yes, sir. Here that HT and TH, this will have the same
HT and
probability.
TH, right?
Yes,
So what we can do, we can toss the coin twice, right? So we can
okay,
write
sir.
if we get HT, if we get HT, we call that success. If we get TH, we call that
Okay, sir.
makes sense, right?
With the same.
So
Okay, sir.
we are just trying to get an event that has the equal probability. And if we get HH or TT, we let go of that. We toss the coin again.
Okay, sir. Okay, sir.
That makes sense, right? Your approach was correct. We are just trying to eliminate the P out of it.
Okay,
So we
sir.
are trying to obtain events that do not depend. So basically that have equal probability.
Okay, sir.
This is called the von Neumann's method. So this has one complication that if P is very small or very large, this does not like work well in the practical situation. But good. I could not think of it when I was given this problem. Uh, okay. So do you want me to ask some questions from distribution theory?
Yes, sir.
Okay. So if you have like two random variables, x and y independent, Poisson lambda1, Poisson lambda2, x and y. So x is Poisson lambda1, y is Poisson lambda2 independently. Can you calculate the conditional distribution of x given x plus y equals to n?
Sir, x plus y equal to?
N.
Okay. So, sir, we shall start with the probability x equal to x given x plus y equal to n. So, we can consider it as a breakdown as probability x equal to x intersection x plus y equal to n. And in the denominator, we will have x plus y equal to n. Now, by the reproductive property of Poisson distribution, we can say that x plus y, as they are independent, will follow a Poisson lambda 1 plus lambda 2 distribution, which means lambda 1 plus lambda 2. And now we can break it as probability x equal to x and y equal to n minus x. And in the denominator, it will remain as x plus y equal to n. So after that, as x and y are already given as independent, we can break it down x equal to x and probability y equal to n minus x. And in the denominator, it will be probability x plus y equal to n. So after that, the PMF will be e to the power minus lambda 1 into lambda 1 to the power x and divided by x factorial. And here e to the power minus lambda 2 into lambda 2 to the power n minus x by n minus x factorial divided by e to the power minus lambda 1 plus lambda 2 into lambda 1 plus lambda 2 to the power n divided by n factorial. So now e to the power minus lambda 1 and minus lambda 2 will cancel out from both numerator and denominator, and we will left with uh, the n factorial will go in the numerator, n factorial by x factorial into n minus x factorial. And here we will have that lambda 1 to the power x into lambda 2 to the power n minus x divided by lambda 1 plus lambda 2 whole to the power n. So it will be NCx, and this we can write it as lambda 1 by lambda 1 plus lambda 2 whole to the power x and into lambda 2 by lambda 1 plus lambda 2 whole to the power n minus x. So this is nothing but the PMF of a binomial distribution, binomial n comma p equal to lambda 1 by lambda 1 plus lambda 2.
Perfect. Good. Another question, we have xy as bivariate normal 0, 0, 1, 1 row. You need to show that x plus y and x plus y are independent if and only if rho equals to 0.
X plus y and x minus
X
y.
minus y.
Sir, we can consider the covariance. Uh, Sir, I think we don't need the validation of rho equal to 0 because the covariance will be always equal to 0. The variance of x plus covariance,
You've
variance
written
of
the
x.
question, independent if and only if. The question is if and only if. Right.
Okay, sir.
Now you can proceed.
So if you consider the covariance, then it would be variance of x minus covariance of xy plus covariance of xy as covariance of yx and xy are same minus variance of y. So these two will cancel out and variance of x equal to 1 minus variance of y equal to 1, this will be 0. So here, sir, we don't need whether the row is 0 or not. If row is not 0, then also x plus y and x minus y are independent until sigma 1 square and sigma 2 square are equal.
Okay.
And sir, if the opposite part, when we are given that if rho equal to 0, then we can say that x and y are IIT normal 0, 1 distribution. So here also x plus y will follow a normal 0, 2 distribution and x minus y will follow a normal 0, distribution. Both will be here. Also, we can find that covariance of x plus y and x minus y, and it will be also coming out to be as 0. So if rho equal to 0, then also they are independent.
So covariance equals to 0, does that mean independence?
That in case of normal bivariate normal distribution, if covariance is 0, that will imply independence. But
Why
in the
so?
other district for sir, because the bivariate normal theorem, uh, we did something as if x and y will follow bivariate normal distribution of the theorem uh, only when if and only if that ax plus by will follow a normal distribution. So that actually in case of normality, the covariance is in terms of linear factors. So I think for that, in case of normal distributions, the if rho is 0, then it will imply independence.
Okay. Can you define convergence and distribution for me?
Yes, sir. So if we consider xn to be a sequence of random variables uh, with sequence of dx, sequence of dx, that is distribution function fn, then we can say that we say xn to convergent distribution to a random variable x only when limit n tends to infinity f of xn will be equal to fx for all continuity points point of x.
Continuity points of x.
Sir, it is going to the x random variable. So all the continuity points at all continuity point of x, if limit fn x is equal to fx, then we will say it is convergence and distribution.
Continuity points of Sorry, what have you written? Limit what?
limit n tends to infinity, f of xn equal to fx.
At all continuity points of fx.
So it will be fx.
I think so. Okay, I mean, it's actually the same thing.
It is fx. All continuity points x of fx.
Fx. Right. Thanks. And how would you define the convergence and probability?
Okay. Sir, in the same way, if xn be a sequence of random variable, then we say that xn converges to x if in probability if probability xn minus x is less than mu is less than some epsilon, but epsilon is greater than 0 tends to 1 as n tends to infinity, where epsilon is
What is
greater than 0.
epsilon? So if you're saying this should hold true for all epsilon or for some epsilon?
No, sir, it will hold for all epsilon greater than 0.
For all epsilon. Okay. So does one imply the other, the convergence in probability and distribution?
So the convergence in probability implies the convergence in distribution, but not the reverse.
So can the other way around never be true?
Sir, the round can be true if xn converges to a constant c, then convergence in distribution and convergence in probability will be same. It will converge to probability also to c.
Okay. That's correct. Can you give an example where convergence and distribution is not implying convergence and probability?
Okay, sir. Then if we can think of x follows a normal 0-1 distribution, and then as it is symmetric about 0, we can also say that minus x will also follow normal 0-1 distribution. So now if we define a particular random variable as y, when or we can also define x to be like it should take xn. It will be x when n is say even, and it will take minus x when n is equal to odd. So in that case, we can say that if we as for all x and n values, it will always normal 0-1. So it will always converges in distribution to, or converges in law or distribution to x following a normal 0-1 distribution. But if we consider the case of convergence in probability, then let us suppose take the value n to be some 2m, and probability then we can say x 2m minus x. If we consider, then it is less than epsilon. So, or better, we to show to disprove it, we should take it as 2m plus 1, as I have defined here minus x here. So if it is 2m plus 1, then it will be probability minus x less than epsilon. So it will be probability that 2x modulus is less than epsilon, where epsilon is greater than 0, any value greater than 0. So probability mod x will be less than epsilon by 2, and we can and it can be written as epsilon minus cap phi of minus epsilon by 2. So this does not goes to 1 as n tends to infinity. So we can say that it does not goes converges in probability to x.
Correct. Good. That's it from my side, Soumyojit. Now Dishari will have statistics.
Okay. Soumyojit, just a follow-up from the previous question. Can you give me an example where convergence in distribution implies convergence in probability? Just any example that you would like.
And in case it goes to a constant, so we can say so we have to generate something that convergence in distribution to a constant.
Can you generate something right now? Do you have something in mind? Let's say xn is a sequence of random variables. Okay. Xn is a sequence of random variables. Can you find a form of xn such that it goes in probability to a constant and it also goes in distribution?
Ma'am, if you consider xn to be c plus 1 by n for all values of n, then I think it might happen that it goes to c as in distribution and also in probability.
Just write it down. You're probably correct. Just write it down.
Maybe with probability 1 and 0 other.
So xn goes to what in probability?
Ma'am, xn goes into probability c.
So does xn go to probability in C? Can you say it directly, or can you say that it goes to distribution in C directly? You have to show probability convergence with the epsilon exam
Yes,
form, right?
ma'am. So xn minus c, if you consider it to be less than epsilon, then probability that will lie between c minus epsilon, xn, and c plus epsilon. So it will be something f of xn plus epsilon minus f of xn is c minus epsilon. And if we consider the CDF of xn, so it will be 0 if x is less than c plus 1 by n, and it will be 1 if x is greater than equal to c plus 1 by n. So if it is greater than c, so then we can consider it to be 1, and if it is less than c, so for large n, so we can consider it to be 0 and it will go to 1. So as it also goes to the constant c, so it will also go to distribution to the particular value c.
Good. Okay. Let's say x and y are two IID random variables. Okay. Can you show that the distribution of y minus x is symmetric?
Just consider z to be x minus y. So probability of z is less than equal to z. So x minus y is less than equal to z. And z belongs to if we consider so here minus z is less than equal to y minus x. So we can write it again as y minus x is greater than equal to minus z. And as x and y and IID, so the distribution of x minus y will be equally distributed as x, y minus x. So here also we can say that z is greater than equal to minus z, and this will be 1 minus f of z, and it is f of z here. So it is 1 f of minus, yes, 1 minus f of minus z equal to. So we can show that it is symmetric about 0.
What do you know about unbiased estimators? What is an unbiased estimator? Can you formally define?
Okay. Ma'am, if we consider that x1, x2, and in this way xn follows a distribution, it comes from a distribution. From a distribution with PMF or CDF f of x theta, where theta belongs to the omega. Omega is the parametric space. So then we consider then T of x curve. It can be considered as an unbiased. It is a function of the sample. It can be considered as an unbiased estimator. Is an unbiased estimator for a parametric function phi theta. We consider if expectation of T is equal to phi theta for all theta belongs to omega.
Good. So, is it possible that I don't take the entire sample, just few parts of it, and still construct an unbiased estimator?
Yes, ma'am. We can also, it is also possible. If we can take only one sample point, also it's also possible.
So why do we always take the entire sample and all the theorems and everything? Better information.
Ma'am, if we consider the sample, so yes, ma'am. If we consider the sample, then we can possibly generate a complete sufficient statistic out of it, which will contain all the information about theta. Maybe a sufficient statistic that will contain all the information about theta from the sample, which will help us in a better construct a better estimator for the parametric function.
So does an unbiased estimator always exist for a parameter?
No, ma'am. It is not always possible to construct an unbiased estimator for a parametric function.
Can you give me an example?
Yes, ma'am. Now, if we consider, let's say that x follows a binomial random variable n comma p, then I think that 1 by x, then if we construct a parametric function as 1 by p, then it is not unbiasedly estimable.
Right. Okay. Let's say x1 up to xn follows uniform 0, theta.
Are they independent?
Independent, random sample. So what is an unbiased estimator of theta?
Then for unbiased estimator, we can consider the sample mean first. So if it is the sample mean, then if we take the expectation, it will come out to be as population mean, that is theta by 2. So if we take expectation of 2 by n, summation xi, I runs from 1 to n, then it will be an unbiased estimator of theta.
And what is a sufficient statistic for theta in this situation?
Okay. So if we consider the joint probability, then we can see this is 1 by theta to the power n, and when 0 is less than equal to xi, less than equal to theta, and 0 otherwise. More specifically, we can write it as theta to the power n when 0 less than equal to x order 1, less than x order n, less than equal to theta, and 0 otherwise. So here we can construct the function as we can construct the two indicator function. First as I of 0 comma x order 1, and the second one as indicator x order n comma theta. So here by Neyman-Fisher factorization theorem, we can consider this part, that I of 0 comma 1 by n to be h of x vector, and the remaining part as the g of t x squared comma theta. So here the g of t x squared comma theta is a function of x theta and x only through tx, and here tx is x order n. So x order n is the sufficient statistic for theta.
Is this statistic also complete?
I think that we need to check.
Can you check? Can you define completeness for me first?
Yes, ma'am. So, family of distribution is a family. If we consider that x order n to be a complete statistic, or rather than in general t is complete for the family of distribution fx theta, then expectation of gt, this 0 will imply that probability gt equal to 0, that is 1. Then gt will always take the value 1 for all theta belongs to omega.
GT will always take the value 1, or GT will take the value 0?
0. Sorry, if you take the value 0, that's probability.
Can you try to show that x order n is complete or not complete?
Okay.
What would be your approach? Just
Ma'am, if I consider the expectation of some function of x order n equal to 0, and then proceed with the distribution of x. So
how would you compute the expectation? Can you just give me the expectation? You don't have to equate it to 0 or anything. Just expectation g of t being the statistic, is 0. What would be the form?
ma'am, so GT here any function of x order n, so we need to compute the PDF of x order n. So in that case, probability x order n is less than or equal to x will be same as probability all the sample values less than or equal to x. That will be x by the whole to the power n. So if I consider x order n equal to x, that will be n x to the power n minus 1 by 0 to the power n, where 0 is less than x than theta. So now, if I consider expectation of gt equal to 0, then integration 0 to theta g of t into n to the power n minus 1 theta to the power n dt equal to 0, and 0 to theta g of t. So as theta here is non-zero and n is also non-zero, we can multiply here in that side. So t to the power n minus 1 dt equal to 0. So
okay, you can compute the rest. Compute the rest. It's okay. Okay, so you said that x bar, 2 x bar, right? It's the unbiased estimator for theta, right? And x order n is the complete sufficient. I'm telling you it's complete. Okay, so can you tell me about the MVUE of theta from these two informations?
So, ma'am, here the second one, that is the x order n, is based on complete sufficient statistic. So, by Lau-Blackfield or by Lemon-Sheffy theorem, we can say that it will be a better estimator of theta rather than 2x bar, because 2x bar is not based on the complete sufficient statistic.
Okay, so how do you compute the MVUE from an unbiased estimator and a complete sufficient statistic?
Okay, so ma'am, here if we consider the expectation of for the case of the uniform 0 theta.
Yes.
Okay, so we can consider compute the expectation of x order n. So it will be n to the power n to the power n minus 1 into dt. So if we compute it, then it will be t to the power n plus 1 by n plus 1, 0 to theta. Then n by n plus 1, 1 by theta to the power n into theta to the power n plus 1. It will be n by n plus 1 into theta. So we can say that expectation of n plus 1 by n into x order n will be an unbiased estimator of theta, and as it also based on the complete sufficient statistic, it will be the UMPV.
Right. Okay. So by Rao-Blackwell theorem, the unbiased estimator, the conditional expectation of the unbiased estimator given the complete sufficient statistic should also give the MVU, right?
Yes.
So it will give n plus 1 by n into x order n.
Yes, ma'am. As here T is complete sufficient. So in case of complete sufficient statistic, I think the Rao-Blackwell theorem and Lehman-Shetty theorem will give the same UMPV. But if T is not complete, then we have to check.
So we are using two different methods to get the same MVU.
Same. Yes.
So why is that happening? Is UMVV unique?
Ma'am, UMPV is only as it is based on the complete sufficient statistic, or we have to show compare the variances of the UMPV. If we consider uniqueness, for uniqueness, we can consider two different. Uh, uh, we can proceed with the contradiction that T1 and T2 is UMPV. Then, after certain computation, we can say that T1 will be equal to T2. So, like that.
So since they are UMPV, they should have the same minimum variance basically.
Yes.
Minimum variance should be the same. Okay, I'm done. राघव वीडियो ऑफ कर देना अगर कोई फीडबैक हो या कुछ हो।